Hello. Today's topic is next part of making simple data pipeline with AWS infrastructure, following from video part 1, which I've uploaded several weeks before. This is the logic I've made in previous video. As you see, message from some of other system is coming into Kinesis stream, and GlueJob will ingest the data from here. After that, it will be stored as a data in S3. Now I'll set up Glue Crawler here to make catalog of data in S3 so it can be used as dataset. After that, it can be used in Athena by specific SQL query, or can be shown as graph or chart with visualization tool. Before that, there are several parts needs to be updated in previous code. This is the glue script which I have created on previous video. There are several parts to be updated. First, we need to make some transformation for raw streaming data. As you see here, output for Kinesis has following JSON format. It has data, which is base64 encoded data of input, and partition key, and other several metadata. The thing only we need here is value in data key. So before writing output, we need to select data column and serialize with input schema. Let's get back to code. There are code for reading input stream. So first, let's define schema for output. On input data, we have two columns, URL and method. Both are string, so make new val demo schema and define a struct type. There are two parameters, so list, and first will be URL. So field is URL and type is string. And copy this, make one more for method. Now make a transform df, which will be the transform result. It will be data frame. So start with df. So select, get the data column here. Call data with cast this to string and put this to the from JSON function for serialization, and put second variable as the defined schema, which is demo schema. And let's rename alias as logs. Okay, now we got JSON data, and select logs dot stars. So only get this selected data. So it will only contain the main data information which has been serialized. Now here's data as data frame, so we need to write it to S3. For this, here I'll use which is in glue the for each function in glue context for each batch function. This is to send streaming source with microbatch. there are three variables, and the first one is frame data. So put transform df. Next, it'll be the batch function to make output from input in batch. This function has two input parameters. First is dataset, and second will be the ID as long variable. With dataset here, we will think of making batch job to write the data to S3. Well, we don't need to write the data if there are no data in data frame. So if data frame count is bigger than 0, we need to only run in this case. First, let's define file path to define the path where data will be stored. So it'll be start with S3. Let's define as glue data storage bucket as output and put data as subdirectory here. And I'll put the directory path as the date information. So let's get current year data. And copy this and get month and date. And make a format with this 3 variable. Get string and string and string. And we will write this data to file path with glue context. Get sync with format. And for the parameter, first is connection. The destination is S3, so S3 here. And format, this is the output file format. So we are going to make this as part.of. And last is option, which is to give the option for the file sync. So JSON option, and inside as map format, we'll give the path here, and it will be the file path. And last, give configuration for this batch with JSON option with map. First will be the window size is to define batch duration. If data is big, it needs to be short. But for this, just set with 30 seconds. And give checkpoint location to decide directory to store checkpoint data of streaming. Let's put as S3 with same bucket name above and checkpoint. And finally, add job commit and yeah, add one missing curly brace. Okay, let's check if there is some missing. Oh, yeah, there are important things which is missed. Yeah, to write the data with this sync format, let's give write dynamic frame. This is to write the actual frame data with the sync configuration. So give dynamic frame, and first parameter is the frame data, which yeah, typo is something weird. So frame, okay, and next is glue context. Okay, it looks okay for now. Let's go on to CDK part to fix infrastructure. Now I'll make some change from previous code in the CDK part. Looking on glue job stack, instead of allocated capacity, let's define worker type. It is not an error, but inside document, it seems it recommends to go on this way. First, set up worker type. Okay, for this, you can find several options for this in document. There are G.025x, and also you can select G1x or G2x. But here I'm gonna use 0.25x because it uses most lowest resource and I don't want to spend much cost here. And for a number of workers, this is to define how much workers you're gonna use. And I'm gonna set this to, this is the least value. And glue version will be the newest one, 3.0. Okay, and we are not going to use this, so remove it. And let's set max retries as 0 to avoid retries. It can cause some unexpected running. Now let's start to add the resource for glue crawler. Name class glue crawler. Resource and cdk.stack. Make init function. Let's copy and paste here and change some input parameters. Remove this ones, and we need crawler role and a glue db and bucket. Here add crawler configuration with AWS glue cfn crawler. Give name as stream data crawler. And give name. And for the role, we have input here, so crawler role and get from role ARN. And it needs database name to define the DB where crawled result table will be added on. Database name is input glue DB as string. And the table prefix, let's define as API log. This will be the prefix of the table. And targets, to define target resource which crawler will crawl. Define AWS glue CFN crawler with target property. And we will crawl the S3 resource. So S3 targets and define with the input will be array and define with AWS glue CFN crawler with S3 target property. Here the path, this will be the path where the data has been ingested from glue job. So it will be, let's make as, let's give bucket name and format this with parameters in input ETL bucket and bucket name. This is okay for targets. And configuration. If you check the documents for this, you can find guide how to define crawler output, including schema, partitioning, and some limitation, and more. There is too much thing to consider here, so I'll not talk about detail here. But for reference, I'll make a table here, table grouping policy as combine compatible schemas. It is to create a single schema for each S3 path and crawler output to define the output format. Partitions and add or update behavior as inherit from table to update all new and existing partitions with metadata from the table. Okay, let's format this as a string and copy and paste here. Okay, don't forget to put version information here. And last, schedule. To define the crawler schedule, put the schedule property. Let's define as expression with Chrome format, and I'll define as once in an hour, like this. Okay, so this crawler job will be run every hour on 0 minutes. So this is all for CDK infrastructure part. And for testing, I've made simple runner script to push messages to Kinesis input stream periodically. Here, assume that there are 3 types of APIs, named as hello, world, health, with 2 kinds of method, get and post. Inside permanent loop, and make payload first with URL and method, which will be selected randomly, and call put record, and call sleep for 10 seconds to make this run every 10 seconds. This is all for the code, so let's see how it looks like after it has been deployed. It all has been deployed, so let's check the CloudFormation first. Okay, all stack has been deployed well, including the crawler. Let's move on to glue job. Here, the job. Okay, one job here, and script has been updated correctly. And let's check the details here. Glue version, worker type, number of workers, it's okay. So let's start running. Now job has been started. Well, so let's push the data from the Python runner.py. Okay, so data will be pushed to the Kinesis stream, and glue job will ingest from that stream. Let's fast forward. We don't need to wait every 10 seconds. Okay, I've stopped it, and I've stopped the job. We don't need to keep running because all push data will be ingested now. Okay, let's check the S3 to confirm the data has been ingested. Data here and checkpoint. So yeah, seems the data has been pushed, and you can find the directory with year, month, date. And okay, there are 4 Parquet files which has been ingested from the glue job. Now let's move on to crawler to crawl the ingested data to generate the catalog. Anyway, it'll run every 0 minutes, but it can be done by manually, and we don't need to wait. Click crawler, and it has been deployed correctly. Let's go in and check some configuration, and data source has been defined correctly. So let's start running, and it has been started. Let's fast forward. Now, yeah, crawler has been done. Seems table has been changed. So let's go on to table. Yeah, there are API log data, which has been classified by Parquet. Let's go in, and in schema, you can find URL and method in string. And there are partition 0, which has been generated by crawler, which is column for partitioning the table. It is defined by subdirectory. Let's look on the result. Click view data, and you can see the data through Athena. Run with SQL query, source name, based on data source, DB name, and table name. And here you can see the result table. There are URL and method info, and partition data as year, month, date, which is directory defined on glue job. This is it for the current topic. I hope this has been help on your work. See you on next video.